Domain and range. You've heard of them before. I wish you could see me right now. I'm waving my arms wildly because I'm so excited about this stuff. Domain is something you've heard before. Like I said, this is x values. And to be more technical, these are the x values that we see in a graph or we see in a function or that we are using in some context. So what x values am I using? And then the range is going to be y values. And then up at the top of your paper, there's these two random pieces of kind of, not punctuation, I don't know what you'd call them, grouping symbols. And this is what I used to call a bracket. Technically, the name for it is a brace. I might use either phrase, or either word, even though technically it is a brace. And I'm just going to draw a little arrow to that, and I'm going to say include. And on that one, I'm going to say does not include. And this makes no sense yet out of context, but I'm just going to keep writing. And then I'm also going to say never include infinity. Okay, and it's important, so I'll put an exclamation mark. All right, so far you have seen two words that you already knew the definition for, and now we have just some random stuff talking about including and not including and never include infinity. And now we're like, what is the context for this? So let's just jump right in. State the domain and range for each of these, and I'm going to do some of them in more than one way so you can see the context for them. So the domain would be the x values. So let's just go ahead, let's use purple. Let's go ahead and say that this is going to have a domain from, okay, x values. What I like to do when I do this is just move my hand or a ruler or something and just decide when am I hitting the graph? Like when does the graph exist? Does the graph exist here? Well, the coordinate plane does, but the graph itself, this little segment of a line, does not. So not yet. No, 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 yes. Okay, let me try this again. Kind of make some sense of it. The graph does not exist at where x equals -5. The graph does not exist where x equals -4.5. The graph does exist where x equals -4. So no, 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 yes. And so my domain is from -4 all the way to, so yeah, my graph exists, see, down there it is, there's my graph, it's existing, my graph keeps existing, it's existing, my graph exists, now it's in the positives, and it's at x equals +2, y is 1, my graph exists, and then now it doesn't. So my graph exists from -4 to +2, so if you want to write it as an inequality, you could say x is in the middle of -4 and 2, and to be technical about it, my domain does include -4. Oh, using a word here. It does include -4 and it does include +2. So I would put less than or equal to. Are they always less than or equal to in this case? Yes, actually. The context for this is that technically x is between -4 and +2. If you want to read it differently, and we've been through this in a different lesson, I would say that x is less than or equal to 2. And we can read this one backwards, which is a little confusing, but we'll read it backwards. X is greater than or equal to -4, which is true. I've got x's that are greater than -4. I've got x's that are less than 2. It's the ones in the middle, okay? And equal to both ends. So now to talk about what this means. Well, because it does include, I'm going to use what's called interval notation. We're dealing with an interval, and I'm going to write this answer in red. So this answer is the same as what I'm about to do here. It's going to go from -4 to 2, and it looks kind of like a coordinate, but it's not. But I do include -4, I do include +2. So this is a faster way, in my opinion, of writing the same thing. So be used to both of them. Get used to both of those. So let's also deal with the range, and we'll use purple on that one as well. So range, going to be the y values. So same thing, but instead of waving my hand like this to say, ooh, what x values am I using? Now I'm going to wave my hand like this to say, what y values am I using? All right. What hard to say. What y values am I using? What y values? Okay, well, do I have a y value of -3? No. Do I have a y value of -2.5? No. Do I have a y value of -2? I do. So this thing starts, this range begins to exist. I like to go from bottom to top at -2. And do I have an output y value of -1.5? Yeah, -1. Yeah, yep. Yep. And the y values are going to end at 1 because beyond 1, we don't have a graph that corresponds to anything. So from -2 to 1, don't put an x here, put a y. And it does include a y value of -2. It does include a y value of 1, so less than or equal to on both of those. And you guessed it, you know what's about to happen. We're going to write this using interval notation. The range does include -2 and does include 1, so -2 to 1 with the brackets. Okay, first problem is done. We're going to go a little faster on some of the rest of them. We will not write the less than or equal to, greater than, if necessary, on a greater than. Actually, we won't need that. We won't do that on all of these, just a handful of them, and we're going to get more used to the interval notation. Also, I'm tired of writing domain and range already, so for each of these, I'm just going to put D and R. So if you want to take a minute and just put D and R for each of these, you may. Skip the next few seconds of the video if you like. Domain and range, domain and range, domain and range, domain and range. Okay, ready to move on. I will use the inequalities at first, and then we will talk about the interval notation on them. So here goes. Inequality for this one. What x values am I using? You can just hold your hands out like this and see what x values you're using. You can hold this one in your hand, or between your hands. From -2 to +5. That's it. This graph exists for x values between -2 and +5. So -2 to +5. Closed circle, so does include yes. All right, let's deal with the y values. So don't hold your hands like this, you hold your hands like this. So from bottom to top, always go from small number to big number, so left to right or bottom to top. Always. I'd never put them backwards. That's just terrible. Don't do that. It's like you're counting backwards. So this graph begins to have y values at -3 and ceases to have y values at +4, including -3 and including +4. So -3, y, +4, and these are going to include -3. Notice the closed circle, include +4. So switching colors, you've seen this, you just saw it, you know what's about to happen. Instead of writing the domain this way, I could write it from -2 to 5 with this, what I used to call a bracket, it's a brace, and from -3 to +4. I have called it a bracket on this one. Oh well, you know what I mean. Okay, next one gets a little bit tricky. I will use the inequality notation and the interval notation on this one as well, and maybe on the next one. And after that, I'll just jump straight to the interval notation. All right, let's go. What x values am I using for this little piece of a parabola? It's just a piece. So the domain, let's see. The domain begins, no. Yes, at -1. Yes. The graph exists, and it ends at +2. Okay, sounds good. So from -1, less than or equal to x, less than or equal to +2. There we go. You know what to do with the interval notation. The range looks easy, and there's a little trick to it if you're not careful. So what are the outputs? That's really the question for range. What are the outputs for a function? And the outputs in this case are 0 and 1, 2, 3. Oh, and it ends. No, it keeps going. It goes all the way up to and includes 4. So when you're thinking of does it include, not include, it's not always going to be a circle that's open or closed. It might be just a graph that exists, and there might not be anything special about that point other than it being a maximum or a minimum, but it won't have some big bold dot there necessarily. But the range goes from 0 to 4. 0 to 4. And it does include 0. Notice the filled in circle. And it does include 4. Notice that it exists. That's it. Okay, so here goes. This one's going to go from -1 to 2. We haven't used parentheses yet. We keep using the braces. 0 to 4. All right, get ready to use some parentheses here. Domain on the next one. Where does the graph exist? For what x values? That's really the question. For what x values does this graph exist? -3, no, 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 yeah, no, yeah, that's where it begins. So -2, but does not include. So -2 less than, but not equal to x. So I have x values that begin at -2, proceeds, yep, ends at 6. There we go. And it does include 6. So when I do this one in interval notation, we're going to mix parentheses and brackets. So does not include -2, does include 6. Brackets, braces, whatever. Okay, you're probably looking at this thinking, what happens if you have an open circle on both ends and you have -2, 6 with the parentheses on both sides? Doesn't that look like a coordinate? Yeah, it does. So you really have to look at the context to see exactly what you're dealing with. Are you dealing with a coordinate? Or are you dealing with an interval? In this case, it's an interval. Okay, the range. The outputs begin at -2, but don't include -2. So my outputs are -2, not including -2, and it's not this -2, it's the y value, and it goes up, up, ends at 2, and it does include 2, so there's that. All right, final answer on that one is going to be -2 to 2 with a brace. Okay, let's go faster. What I did not have on the next one, sorry, I'm clapping right in your ear. What I did not have on these is arrows, and I should. So now we're going to get to some things that involve infinity. So if you feel the need to put arrows on these, you may. So here goes. The domain of this one, and I'm just going to jump straight to interval notation on this one, all right? Let's see. My domain begins at -3, including -3. So I will include -3, and keeps going, keeps going, keeps going. It ends never. So no matter how far I go to the right, there will always be a graph that exists. It's going to go way up, but it's going to exist. So from -3 to infinity, never include infinity. Never put a brace on infinity. Always put a parenthesis. Always. Okay. The range is going to start, y values, so down here at -2. So -2, and it does include -2. Make that look more brace-like. And it goes up. It goes up. Does the graph exist as we go up here? Yep. Does the graph exist here? Yep. Does the graph exist here? Yeah. Here? Yeah. Here? Yeah. Yeah. Forever. Because the graph goes up forever. It goes to the right forever. Notice the domain here. But it goes up forever as well. And there's that. Okay. If you want to get technical, if you wrote these as inequalities, this one would be x values that are greater than or equal to -3. And that covers infinity for sure. And the range would be y values that are greater than or equal to -2. All right, speeding up a little bit here. Here we go. Grab your red pen. Let's move. Domain in this case begins at -3 but does not include -3. So -3 parenthesis on that one. And it moves forward, and it moves forward, and it keeps on moving forward. It's going down, but no matter how positive I get, I will have a graph that corresponds to my x value. So infinity. Okay? Range. Tricky. I like to start at the bottom and move my way up. So if I started down here at -3, does the graph exist? Yeah. -2, yep. All the way up to, but not including 2. And so I would start way down here. And if I did, well, I'd keep going down and down. Now, I know it's going to the right, but it's also going down, so negative infinity. And we have a visitor. How you doing?
I'm sorry.
You're fine. I do. I have everything I need.
I'm sorry.
Oh, you're good. You're good. Thank you.
Thank you.
All right, let's move on to the next. You're wondering who that was, weren't you? Sweet little custodian asking if I have enough tables and chairs, and I do. Okay, domain on this next one. How far to the left do I go? Like if I was to start this and be like, oh, it starts at, no, it doesn't start here. It started way back to negative infinity because this thing moves all the way to the left. It goes up pretty high, pretty fast. But yeah, negative infinity and goes all the way to the right to positive infinity. Okay, range. What outputs do I get? What y values do I get? -3, yeah, -3. Yeah, -3, like parenthesis or bracket, brace. Brace. Okay, there is an output there. And I know there's an output there because, well, it's just a standard parabola. There'd be an open circle otherwise. It's the same situation as that. And it goes up forever, which I would like to think is a little bit obvious. Never put a brace on parenthesis. Never put a brace on parenthesis. Never put a brace on infinity. Okay, last one. This was pretty straightforward. Domain, negative infinity to positive infinity. You're going to encounter that a lot with almost every single line that you could think of. Unless the line is horizontal, then you'll have a domain of negative infinity to infinity, but your range will be stuck at one number. It's weird. All right, range in this case, well, it goes down forever. It goes to the right as it goes down, but goes down forever. It goes up forever. So any y value you think is going to have an output, and that's it.